Okay, here we are. Today is day 23 in the Advent of Cyber Challenge, and today's challenge is AWS Security Secret Santa. Of course, we have our two associated videos here. And in today's challenge, we have 5 tasks. So introduction, IAM, which is users, roles, groups, and policies. Practical, so we're going to enumerate a user's permission. Task 4, assuming roles. Task 5, grabbing a file from S3. And we'll go ahead and kick it off with task 1. But before I do that, my disclaimer as always, I'm not a cybersecurity professional and I have no experience in or with cybersecurity. So you'll see me taking on these challenges as a beginner, just like other beginners would. And of course, here we go. Today is day 23. All right. So one of our stealthiest infiltrated elves managed to hop their way into Sir Carrotbane's office, and lo and behold, discovered a bundle of cloud credentials just lying around on his desktop, like forgotten carrots. The agent suspects these could be the key to regaining access to TBFC's cloud network. If only the poor hare had the faintest clue what the cloud is, he'd burrow in himself. Okay. Let's help the elf utilize these credentials to try and gain access or regain access to TBFC's cloud network. So in this one, we're going to be learning the objectives such as learn the basics of AWS accounts, enumerate the privileges granted to an account from an attacker's perspective, and familiarize ourselves with the AWS CLI, so command line interface. In this one here, we'll review the questions and the connection card below. So for today, we're just going to need the VM. We get that in split screen. And right here, we'll just go ahead and kick off the attack box, or I'm sorry, the target machine. Close these pop-ups. All right, so AWS accounts can be accessed programmatically by using the access key ID and secret access key. For this room, both of those will be automatically configured for you. The AWS CLI will look for credentials at, and we can see that here, where you should see something similar to the following. So we'll see an AWS key, ID, and a secret access key as well. Amazon Security Token Service, so STS, allows us to utilize the credentials of a user that we have saved during our AWS client or CLI configuration. We can use the getCallerIdentity call to retrieve information about the user we have configured for the AWS CLI. So we're going to run the following command of AWS STS getCallerIdentity. Okay. So open terminal. And then copy this, paste that. Nice. Ours does not appear there. So we'll do an ls -la. Oh, no. And now my target machine is freezing up. So bear with me here. Maybe we don't need to locate this yet because it's saying AWS CLI. Let me refresh the page here. Certainly not the first time this has happened. I've actually had this happen on a lot of different challenges this year, which has been wild to say the least. And I know there's tons of people that do them, but I did actually purchase the premium subscription to kind of prevent a lot of these issues, but I've actually noticed them more having the premium user account than in previous years where I just used the free access. So I guess we'll go ahead and power down, terminate that, and I suppose we'll start again. So I suppose we will just run this command because it looks like AWS accounts can be accessed programmatically by using the access key ID and the secret access key. For this room, both of those will automatically be configured for you. The AWS CLI will look for credentials at. So I'm just going to go ahead and copy this. Then of course it says once we run this command, we should see something similar here. Seeing the output, the elf was overjoyed, the credentials work. And as can be seen by the name at the end, they belong to S3cret, shown here. Okay, looks like we're loaded up now. So what I'll do is run that command. So we'll try running again in 30 seconds. Okay, so I guess we wait about 20-30 seconds here and see if we can't get access. Let's do this one again. Give it about 3 more seconds here. We'll try it again. All right, let's see. So we do see user ID, then we see the account, and then we see S3cret here. So run the command here. What is the number shown for the account parameter? Well, it's this one here. So we'll copy that, paste, check. There we go. Task 1 is complete. So we'll go ahead and pause there. We'll come back for task 2. Okay, we're back. And before we actually jump back into task 2, I do want to attempt trying to access this info right here, even though it didn't work for me the first time. So I'm going to go ahead and copy that. Let's open a new terminal. And I know it's a hidden folder because we see the period before AWS. So let's do ls-la. And let's see if we can locate that. Yes. So yes, definitely hidden. So we'll do cd.aws. Take a look in there, and we'll see if we can't concatenate credentials. Okay, yeah, there we go. So we do see the access key ID, which is right here, and we see the secret access key, which is right here. Okay, that's just what I wanted to check before moving on. Let's go ahead and drop this. This is our other one here. And I guess I'll go ahead and jump into task 2 now. So IAM overview. Let's go ahead and actually put this in full screen. And there it is. I was like, where did my sidebar go? Go ahead and pull them both open. Perfect. Okay, we'll come back, minimize this. There we go. All right, IAM overview. We'll go ahead and check out what that means. It's identity and access management, stands for IAM. All right, so Amazon Web Services utilizes the Identity and Access Management IAM service to manage users and their access to various resources, including the actions that can be performed against those resources. Therefore, it is crucial to ensure that the correct access is assigned to each user according to the requirements. Misconfiguring IAM has led to several high-profile security incidents in the past, giving attackers access to resources they were not supposed to access. Companies like Toyota, Accenture, and Verizon have been victims to such attacks in the past and often exposing customer data and sensitive documents. Below, we will discuss the different aspects of IAM and that can lead to sensitive data exposure if misconfigured. So IAM users, a user represents a single identity in AWS. Each user has a set of credentials such as passwords or access keys that can be used to access resources. Furthermore, permissions can be granted at a user level, defining the level of access of a user might have. Then we have groups, so multiple users can be combined into a group. This can be done to ease the access management for multiple users. For example, in an organization employing hundreds or thousands of people, there might be a handful of people who need write access to a certain database. And instead of granting access to each user individually, the admin can grant access to a group and add all users who require the write access to that group. When a user no longer needs access, they can be removed from the group. Okay? Then we have roles. So an IAM role is a temporary identity that can be assumed by a user as well as by services or external accounts. And to get certain permissions, think of S3cret and how, depending on the battle ahead, he might need to assume the role of an attacker or a defender. When becoming an attacker, he will get permission to wield his shiny swords. But when assuming the role of a defender, he will instead get permissions to carry a shield to better defend the King Malheur. So IAM policies. Access provided to any user, group, or role is controlled through the IAM policies. A policy is a JSON document. We can always look at that, which is going to be JavaScript object notation. And this document that defines the following: what the action is allowed, so action, on which resources, resource, under which conditions, condition, and for whom, principal. So consider the following hypothetical policy. So we'd see this is the version set date, so kind of like last refined or revised. So we see SID, the effect, allow, principal, AWS, action, S3, get object, and resource, ARN, AWS, S3, my private bucket. So that's the exact file path, I assume. So what IAM component is used to describe the permission to be assigned to a user or group? Well, wouldn't that be policies? Okay, perfect. So we'll pause there. We'll come back for task 3. Okay, here we are. Task 3, practical, enumerating a user's permissions. So enumerating users. All right, let's see what we can do with the credentials we got from S3cret's office. Since we've already configured them in our environment, we can start interacting with the AWS CLI to find more information. So let's begin by enumerating users, and we can do this by running the following command of AWS IAM list users. So let's go ahead and, I thought I already closed this one out. Let's go ahead and, you know what, we'll just clear this. And we will run that command here. And we have S3cret, the user ID, and creation date here. So we'll see the output of the list of all users. I only have one, so hopefully that's all we have. And some additional information as well as the creation date. So we can enumerate user policies. Policies can be inline or attached. Inline policies are assigned directly to the user or group/role. And hence, when it is deleted, the identity is, good night. Profile and hence will be deleted if the identity is deleted. These can be considered as hard-coded policies as they are hard-coded to the identity. Definitions themselves. and attached policies, also called managed policies, can be considered reusable. An attached policy requires only one change in the policy, and every identity that policy is attached to will inherit the change automatically. So we're going to check for inline policies for cybersecurity by running this command here. So let's go ahead and paste that in here. And let's go ahead and delete those spaces. Let's go back. We can paste that here. Run that. And we do see a policy name of cybersecurity policy. So let's just copy this if we need it. Paste that in here. All right, so great. We can see an inline policy in the results. Let's take note of its name for later. And maybe cybersecurity has some attached policies. So let's check for those. And we just copy this, open up our clipboard one more time, paste it in here, clear those spaces, and let's check for that. That parameter looks empty. Okay, so let's go back. So, not much there. Perhaps we can check if cybersecurity is part of a group. So let's do that with this check here. And we can see the previous one was list attached. This one was list user policies. And of course, these are the usernames we're associating. And for here, it's just list groups for the user. Same thing, provide the name. There we go. And looks like no groups as well. So looks like cybersecurity is not a part of any group. So let's get back to the inline policy we found for cybersecurity's account. Let's see what permissions this policy grants by running the following command and replace policy name with the actual policy name. So we'll copy this, come back here, open this up, paste that, and we need to change this with this. So let's copy this. And let's replace it here. And close that clipboard. Let's paste our piece right there. And there we go. So we see our output, username, policy name, creation, revision data, I guess. Actions. So these are the actions they have. List users, list groups, list roles, list policies, both attached for user, group, and role. Get user policy, get group policy, get role policy, get user, get group, get role, and everything down to STS assume role. Okay. So pretty much what is shown here. Effect allow resource SID list entities. Is this just too large? Is that what it is? There we go. Oh yeah, now we got more content. Okay. So it looks like cybersecurity has access to enumerate all the different kinds of users, groups, roles, policies, but that is about it. This is not a lot of help getting TBFC access back, and we might need to try something different to do that. But if you look carefully, you'll notice that cybersecurity can perform STS assume role actions. Maybe that will help. What is the name of the policy assigned to cybersecurity? That was this one here. So we'll copy this, drop that here. We're good. All right, so we'll pause here. We'll come back and do task 4, which is assuming roles. Okay, here we are. Task 4, assuming roles. So enumerating roles. The STS assume role action we previously found allows cybersecurity to assume roles. Perhaps we can try to see if there's any interesting ones available, and let's start by listing the existing roles in the account. So AWS IAM list roles. Let's zoom back out here. And I'm assuming Control C to get out. Yep. And let's paste. Okay, so what was it? AWS, because I did not copy that properly. AWS IAM list roles. Got it. AWS IAM, not typing. Okay. Let's just open a new instance here since it doesn't want to work for me. And try that again. IAM list roles. Okay, so role name, bucket master. That's probably a good one. And we see the creation date, assume role policy document, action, STS, assume role, effect allow. Okay. So we see same output here. Bingo, there's a role named bucket master and it can be assumed by S3cret. Let's find out what policies are assigned to this role. Just as users' roles can have inline policies and attached policies, to check the inline policies, we can run the following command. So we can copy this. Let's drop this on our clipboard. Delete. All right, so AWS IAM list role policies, and then provide the role name of bucket master. We'll go ahead and paste that in here. Run that command. And we see policy names of bucket master policy. So let's do two things. Let's copy the bucket master policy. And let's also spell that correctly. And we'll do a lowercase bucket master roles. Got it. Okay. So there's one policy assigned to this role. Before checking that policy, let's see if there are any attached policies assigned to the role as well. So we'll do that. And we'll come in here to the clipboard, paste that in, and delete those white spaces. AWS IAM list attached role policies, and then provide the role name. Then we'll go ahead and paste that back in here. Run that command and see what we get. So nothing, no parameters there. Looks like we only have an inline policy assigned, so let's see what permissions we can get from the inline policy. Sounds good to me. Let's come back, clipboard. Let's add this new command here. And we see AWS IAM get role policy, role name, bucket master policy name, bucket master policy, which those are both correct. Paste that. Run that command. There we go. We got quite a bit of output here. So we see role name, policy name, the action, S3, list all my buckets. So that is an action. We'll copy this. Action on policy. And then we also have effect allow resource. We also have S3 list bucket. So let's come back here. Paste that one as well. Then we have, so list all my buckets, list bucket. And then we have, let's go ahead and zoom back out. Make sure we're seeing everything, which we are. And we also have get S3 get object. So we'll copy that one as well. I'll add the S and we'll just do S. Oh, let's actually control V. There we go. And let's put some there we go. Get a little bit of space in there. And let's go back. Let me zoom back in just a bit since I'm pretty much blind here. All right, so, well, what do we have? We can see that the bucket master role can perform 3 different actions: list all buckets, list bucket, and get object. Yes, we saw that. On summary sources of a service named S3. Yes, we saw that. This might just be the breakthrough that we were looking for. More on this service later. So let's go ahead and zoom in one more time. So to gain privilege assigned by the bucket master role, we need to assume it. We can use AWS STS to obtain the temporary credentials that enable us to assume this role. So AWS STS assume role -- role ARN AWS IAM. We provide that ID, the role of bucket master, and okay. So our session name, we'll copy all this here. Come back. Let me zoom back out on this one. Sorry, 1, 2. Let's do Control C to get out. And let's clear this up a bit. Okay, let's try that one more time. Oh, it's doing it again. That's fine. We'll just open up a new instance. And we'll paste. Delete that white space. Paste. And run. Okay, so we have credentials, the access key ID, secret access key, session token, assumed role ID here. Okay. So the output will provide us with the credentials we need to assume this role: the access key ID, secret key access, and the session token. To be able to use these, run the following commands in the terminal, replacing the exact credentials that you have received on running the assume role command. Got it. So first, let's grab this. So we'll copy that. And this will be the access key ID. Okay. Then let's go get the secret access key. Come back in here. And then last but not least, we need to get the session token. Nice. And we'll just do, there we go. All right. And come back here. So then we need to run export AWS access key equals with the quotes around it. Close up that, paste it here. And I can't remember, was there a space between? No, there was not. So usually, typically not. And let's go back and grab our access key ID. Nope. And we'll paste that in here. And now we need to run export key for secret access. And let's go grab that. Close quote. And then last but not least, we need to run for the session token. So copy that. Clipboard. Oh, see, I keep clicking out of it like that's going to close and it doesn't do anything. Add our quotes, add that super long, looks like base 64 encoded string here. And I know I probably don't have to use the clipboard, but I just feel like I was having so many issues with the proper formatting earlier that I'm trying to keep from that happening again. There we go. So now we have those three added. Once we've done that, we can officially use the permissions granted by the bucket master role. To check if we have correctly assumed the role, you can once again run AWS STS get caller identity, okay? And let's go ahead and clear that out. And then let's paste that in there. Oh, go back and paste that, yeah. Okay, account number. We did the user ID of. I don't know if we did get it correct or not. So this time it should show that you are now using the bucket master role. I don't think that it does. So did we do something wrong here? Oh, right there. Okay. I'm blind as a bat. So yes, we are in the bucket master role. Phew. Okay. So apart from the get object and list bucket, what other action can be taken by assuming the bucket master role? Well, that was list all buckets. So we'll copy that, paste, and hopefully, nice. All right, so we'll pause there. We'll come back and do task 5. Okay, here we are, task 5, grabbing a file from S3. So what is S3? Before we continue, we need to know what exactly is S3. Amazon S3 stands for Simple Storage Service. It is an object storage service provided by Amazon Web Services that can store any type of object such as images, documents, logs, and backup files. Companies often use S3 to store data for various reasons, such as reference images for their website, documents to be shared with clients, or files used by internal services for internal processing. Any object you store in S3 will be put into a bucket. You can think of a bucket as a directory where you can store files, but in the cloud. So now let's see what our newly gained access to Sir Carabane's S3 bucket provides us. So listing contents from a bucket, we can do AWS S3 API list buckets. Yes. Sorry, I was trying to make certain this is what that said. So since our profile has permissions to list all buckets, we can list the available S3 buckets by running this following command. So the one I just read there previously. So we'll copy that. Come in here and see if it'll paste properly. It did. Let's clear out that white space or dead space, however you want to refer to it. So we have buckets here, the name, Easter Secrets 123 145. So we're going to go ahead and open another new notes page here. And let's copy this one. And let's copy this one. Oop. And what was the last one here? So the buckets, and then we have the owner of web file. We'll just copy this. And we'll do owner. And what was the ID? Grab that too. Oh, nope. And let's go ahead and delete all that stuff out of there. Paste this. So we'll say name, ID, and all right, so name 1 and 2, then we got the file, the owner. Go ahead and just drop that line in here. Let's add a couple of these. All right. Let's go back here. So there's one interesting bucket in there that references Easter. Let's check out the contents of this directory, and by doing so, we can run this command here. So we did see Easter secrets, and let's see if we can't just paste that command, clear out that dead space. And real quick, we did run list objects bucket Easter secrets. So bucket Easter secrets, full name here. So we see the key of cloudpassword.txt, last modified, size, storage class, display name. Then we have groceries.txt. Okay. So let's go ahead and zoom out here just a smidge. Come over to this one. All right. So let's copy the file in this directory to our local machine. This might have a secret message. So we're going to use this command here. I'll close this here. And paste. Nice. Didn't work at all. Let's try that again. Oh, I bet it's because I resized the terminal. Yep. Let's see if it'll let me add it from the clipboard. Nope. All right, so let's close this. Open another new instance. So every time I resize, it keeps throwing it off. An error occurred, AWS. So what were the last three we just ran? We'll do this. Oh no. So now it's saying it's not picking up anything, so that's not good news. Let's do a refresh on the VM here and see if we get some better results. Please work. No. All right, let me see if we're even in. Oh, we're back in S3cret. Are you kidding me? It's because I closed out of that terminal that wasn't working. So I got to rewrite all these again. So let's do this. Copy. So glad I left the notes. All right, let's copy that. We'll remove this one here, add this one. Okay. So we're going to add this one first. Let's delete this, and oh no, undo that. There we go. And we'll copy this. See if it just drops. Nice. Let's do the next one. Oh, back to notes. Copy that. And let's do, I keep going back there. Session token, let's add that. And now let's run this one here. An error occurred, invalid client token ID. When calling the get caller ID operation, the security token included in the request is invalid. Oh, I didn't run export. Got it. So let's add now let's check and see if we're in. Fingers crossed. Okay, we're back to Bucket Master. Holy moly. Now let's go back to task 5. And we did list all buckets. We did do this one. We were running this last one here. Okay. So we have accept ranges, bytes, last modified, content length, etag, content type, and metadata. What are the contents of the cloud.txt file? So if we copied it to our local machine, would it be in here? Oh, it will be in here. Nice. All right, there we go. Task 5 is complete. All right, and let's just go ahead, go back, terminate our machine here. Yes. Close that out. Let's just double up here. And that's it for this task.